Hey guys, today we're going to take a look at scatter plots. So a scatter plot is a graph that shows the relation or relationship between two variables. Relationship. Okay, so wow, there we go. Okay, sorry. So a scatter plot is a graph that shows a relationship. The points in a scatter plot often will show a pattern, or what we usually call a trend. Okay. Using the pattern or trend, you can describe the relationship between the variables. So you can describe the relationship. All right. So here we go. We've got this one here. We've kind of got this downward trend going like that. This one's a little bit more spread out, so it's maybe not as strong. We'll talk about what that means, but it's an upward trend. And then this one really doesn't have a trend at all. It's just nothing. It's nothing, okay? So when we talk about this, we will talk about it as a correlation, which is just another word for the relationship. So actually, I'm going to write that down here too. We call it a correlation. I have to do this so I can spell it right though. 2 R's. Correlation. A little messy on that one. That's okay. All right. So the correlation here is going to be strong or weak. Okay. So if the points nearly form a line, or if they're very close together, it's a clear trend. This is what we call a strong correlation. Okay. However, if they're spread out, that's what we call a weak correlation. Okay, so if we go back to these examples here, this one with the downward trend here, so that was downwards, but it was very strong. Okay, that's strong correlation because look how close those points are to that line that I've drawn. Okay, this one has a much weaker correlation. And then finally, this one here has just no correlation. If there is no relationship, you just say there's no correlation. Okay? So the variables, the independent variable is located on the x-axis, and that's always true. This variable doesn't depend on the other one. It's what determines the other one. So the x-axis is always what determines the other one. It causes the other one to change. Okay? The other one we call the dependent variable, the y-axis, and that's because what that value is depends on what x value we're using. Okay? Often we do graphs with time as one of the axes, and that will always be the independent variable because, of course, time is not affected by other things. Okay? Another definition here that we'll go over here is we got what we call an outliner. So this is just a measurement that differs significantly from the rest of the data. So if we just jump back to the strong correlation, there's a strong correlation there, but if, say, there was a point right there, well, that's an outlier because it doesn't really fit in with the clear trend that we have. Okay? So and that's usually just some sort of anomaly. It's kind of your exception to the rule for whatever reason. Okay? So we're going to take a look at this one here where we have a skateboarder starting from various points along a steep ramp and practicing coasting to the bottom. So the table lists the skateboarder's initial height, the starting height, and his speed when he hits the bottom of the ramp. Okay, so obviously the x value here is going to be the initial height because the initial height's what affects his speed. Okay, so that will be our y. Okay, so our independent variable is height, and the dependent variable is then speed. Okay, the higher we start, the speed's going to be faster, right? It's not that your speed affects how high you started because that part already happened. Okay, so if we graph this, we will hold on. So I'm actually just going to use the magic of the internet here, and there we go. We've got it all graphed. And so basically what we're looking at here is just the trend we have. So if you look at this, these points here, they kind of have this trend, like it's a pretty tight line, right? So that's pretty strong correlation with just sort of this guy right here that doesn't really belong. And so that's your example of an outlier. That's what we're talking about when we say an outlier. Okay, so the trend here is going to, it's an upward trend. I don't know what that's supposed to be there for. So the upward trend, it's going to be pretty strong too. Maybe I'll use a normal color, strong. Okay, with an outlier, we could even say. All right, so there we go. All right, so let's jump over to the next page. And we've got another question here with Julie's height and age. So Julie gathered information about her age and her height from the markings on the wall on her house. So label the vertical axis. So the vertical axis is the one that depends. So obviously her age is not going to depend on her height. It's going to be the other way around. She gets taller, she gets older. So that's her X, and so that's her Y. So that is going to be her height in centimeters. Okay. And remember, labeling these axes, that's where you get those easy communication marks, where just for remembering to do those. Okay, so there you go. So that's done. So we're going to describe the trend in the data. So this is definitely a strong upwards. Strong upwards trend. Sometimes we call that a positive. Strong positive is what's actually more commonly used, but that's okay. Okay. So describe the relationship. When you get a question like this where it just says describe the relationship, this is going to come up quite a bit on tests and assignments and things like that, or the exam, whatever. Your homework, for instance. And what it just means is, like, just explain it. Okay, use words. So the bottom line is, as she gets older, she gets taller. No tricks. That's all I'm looking for. Okay, you're just explaining what this graph tells me. It's just telling me what the data shows us. Okay. All right. So this next one here, scatter plots and line of best fit. We're going to create a scatter plot to display the trend for the percentage of foreign-born players in hockey. So there you go. So there's all our data. And once again, I'm just going to make this happen. And there we go. It's all drawn for us. So again, you can see we've kind of got this upwards trend, and it's a pretty strong correlation, even though it's maybe not as steep as some of the other graphs we've done. That doesn't really matter as long as those dots are nice and close together to forming this line of best fit that we're going to do. So a line of best fit is a line that best describes the relationship between two variables in a scatter plot. So we basically just draw a line to kind of show what's kind of happening or what the trend is. It doesn't actually have to go through all the points. It actually doesn't even have to go through any of the points sometimes, depending how fine your line is. But it's the point that, or the line that gets as close to as many points as possible. Okay? Okay, so to plot a line of best fit, we're going to place a ruler, which I'm not going to be able to do with this tablet, but whatever, you'll get the idea, over the plotted points. That should have an S, so that most of them are, I'm actually going to change this, what it says here, are on the, I'm going to get rid of the word on. I don't like that. I don't like how this is worded. Okay, are, and we're going to say close to. So most of them are close to the ruler with a half of the points. I'm going to get rid of the A. I don't like that either. With half of the points on either side of the line. Okay, the idea is that they can be on the line, but you want kind of half of them to be above it, half of them to be below it. You're just getting as close to that trend as possible. It is also important to note that it is not necessary for the line to connect to the first and last point. It actually doesn't have to connect with any of the points. It also doesn't have to start at the origin. And for one like this, it would actually be terrible, because if you look, and you don't have to write this on your page if you're copying this out, but if I look at this one, I can draw a line of best fit, and this isn't going to be straight, but you can see the idea. I can draw, and it's going to kind of look like that, okay? And that's just me eyeballing it and getting as close to that trend as possible, and it's going to across here. If a lot of the times we'll look at this and try and start at the origin and like, I guess you kind of do that. Well, that looks nothing like what the data looks like. So that's not what we want. Okay? All right, that's it for today. Until next time, go Sabres.